there are quite a few probes out there. So I tried to put together, some recommendations of ones that I use, as well as, I use all of these actually, but some of my favorites. And I divided this into starting off with topography, because a lot of people are just doing topography with AFM, which is fine. And what are the the different probes for topographic imaging? So I separated this into tapping mode, peak force, and contact mode with these first 3 slides here, just to kind of give you an overview on what are the differences. There's quite a few tapping probes out there. The TESP probe, this TSP with an A on the end, is aluminum coated, and of course V2, I explained that earlier. This is an old school probe. So as Ian mentioned, we've been doing this a long time. This is kind of one I started with, and I still tend to use this the most. All of these probes, except for the last one on the right, are 300 kilohertz probes. They're general silicon etched probes. They'll have slightly different geometries though. The TESP, like I said, was one of the first ones, but this is one where if you put it in the tip holder, it tilts it, and the back side's 90 degrees and the front side's 35. So for that reason, we came up with this R-TESPA, and you can almost see the difference slightly. You have the short side over here of the etching on the TSP, and this reversed on the R-TESPA. Otherwise, they're very similar. They're both very good probes. And then there's the O-TESPA and the V-TESPA. This is a very different shape to the probe. They're still silicon tapping probes, very similar resonant frequency and everything, but the tip itself is actually right at the end of the cantilever. And so in this case, you can see that if you look from the back at the optics, the very end of the tip is in the very end of the cantilever is where the tip is. So if I have an application where I'm trying to land on a very narrow area, like a particle or a very specific part of the sample, these are nice probes because the end of the cantilever really is where the tip is. So it has a slightly different shape to it, versus these probes, which are slightly recessed, although still very good probes, and I tend to use these more. And then there's the R-TESPA 150. This one has a slightly lower spring constant, so this would be more like a medium spring constant probe that I mentioned for lower force tapping or playing with the phase. For contact mode, if we're talking old school, there's the DNP probe, which is a silicon nitride probe, and the MLCT. These have multiple cantilevers with multiple spring constants, so you would be applying a different amount of force with this. Also, these are nice for force spectroscopy if you want to detect forces at a different level. Then you could choose very soft probes. There's that 0.01, that real long probe I showed you at the beginning. That's this guy here. So these chips will have multiple probes on each one. This RESP, or the ESP probe, is a contact mode probe made purely out of silicon. It's really long. It's 450 microns long, which is humongous compared to most of the probes you're used to looking at the AFM. I put this in here because I actually use this from time to time. It has a nice low spring constant of 0.1. Also, it's long, and it can sometimes get in little hard to reach places if you have unusual shapes to your samples, like some packaging I've worked with, or like rocks, geological samples, things like that. This probe has really come in handy at times. The FESP I like a lot because it can do contact and it can do tapping mode. It's kind of an in-between probe. It's about 2.8 newtons per meter, but it has a high enough resonant frequency to do tapping mode. So you can do a lot of things with this. You can also do torsional resonance mode with it if you're looking at lateral, feeding back on the lateral oscillation, if you're familiar with that. So this probe can do quite a lot of different things. And so it's kind of one of my favorites as well. For scan assist topography, there's 2 primary probes I use. The scan assist air, which apparently a lot of you are using also, which is good. It's a great probe, nice and sharp, and low spring constant, 0.4 newtons per meter. And then the scan assist air HPI. So HPI is a paddle shaped probe. So it's kind of narrow and then has a wider end to it for better laser reflection. So if you're getting spillover with the scan assist air, then you could use the scan assist air optical light spillover, then you could use the HPI probe. For scan assist, you want probes that have a coating on the backside if you were to experiment with different probes. The SNL probes, another probe that has the 4 cantilevers on a chip, kind of similar to the DNPs, but nice sharp silicon tip. You could use some of the stiffer probes on this for peak force as well. And these are probes that you may have in your lab as well. And then we have probes that are designed for high resolution. So we have a tapping probe, it's called SS, which stands for super sharp, and 2 to 5 nanometers. So it's a nice sharp probe. And then we have a group of probes which are designed for peak force mode. Some can be used in tapping, can be used in air or in liquid, depending on the probe type. And I like this probe a lot. Actually, this is the SAA, which is Scan Assist Air HPI-SS. So it's a 1 nanometer probe on that Scan Assist Air HPI structure. It has a low spring constant, 0.25 newtons per meter. So it does a really nice job at real high resolution. And then this other one as well is very similar, a little shorter probe. So these are both good options. We're getting into high aspect ratio structures like trenches, vias, anything where a regular probe won't quite fit into it because it's too wide on the side angles. There are a number of different probes we make. We take some probes and we'll machine them with a focused ion beam, which actually Ian mentioned at the beginning during his introduction. And we have different lengths, 1 to 7 microns. And we will have different widths of the probe at the base. For the longer probes, we make them a little bit wider because they'll start to kind of flex around if you make them too thin and make them really long. But they're tapered down. They have a nice thin radius of 10 nanometers still. And then we have probes that are grown into the beam, electron beam, and they are made at different lengths as well, 350, 750, and 2.5 microns. So these are designed for peak force tapping mode, these 3 here in the middle. We tend to use the fib probes for tapping. And another nice tapping probe, this is a little more general probe, is the TESPA probe, HAR for high aspect ratio. The spike at the end goes about a micron or 2. I generally expect about a micron or so. And otherwise it performs very similar to a regular tapping probe. And I like this one as well. Also, we make probes we have an automated line of AFMs, which will basically change the probes